Namaskar my dear friends. Let's try to understand how we can do LED selection process. Okay. So there are various applications for these kind of LEDs, as you can see. Some of them are through hole LEDs, some of them are surface mountable LEDs. Okay. So we'll try to understand what are the different parameters that we need to look into so that we can have the best selection for our utilization or our applications. Okay. So the various application of these ICs will be, or these LEDs will be, the PCB indicators. Like you have the printed circuit board, on that some indicators will be there, like let's say voltage rails indicator, like 5 volt indication, 3.3 volt indication, 12 volt indication, or some power supply indications and all. Some of the status indications will be also required. Somewhere you will be charging battery, so you need to have a battery charging indication or battery fault conditions. On off indications, like system has like switch on switch off buttons, so in that you want to see whether it is switched on or switched off. So in that cases also you to try to utilize red LEDs or green LEDs to indicate those functionalities. Okay. And general power good or fault indications. For that purpose or for these applications, we will be trying to select some LEDs that we are going to have. Okay. So let us try to understand what are the various parameters that we need to look into before selecting a particular LED. So first of all, we have to understand who is my manufacturer. Okay, so there are various manufacturers in this industry right now for LEDs. So if I name some of them, they can be like Worth Electronics, and then Light On is there, King Bright is there, Broadcom is there, Osram, Omron, and Vijay. So Vijay Semiconductor is also there. So these are some of the best companies for all your LED solutions or LED applications. Okay. There are some other companies as well that you can like always look into that, but these are the some of them which are like chosen one which I also prefer. Okay. Coming back to the manufacturer part number, that automatically based on the different other parameters that we will look into, we will try to understand what is my manufacturer part number and component description. Okay. So basically component description will include what are the things that we will will be included, whether it is SMD or through hole. Okay. Then what is my size, whether it is a small size or little bigger size or something like that. Okay. Then what will be the color and all. Okay, which color it will be, what will be the lens color. So all these parameters will be included in your description. Okay. So let us see one by one other parameters. First of all, we have to understand whenever you are going to select an LED, you have to see the product status. That product status is active. Okay. So if it is active in the market, like it will remain for around let's say 10 years or 20 years, coming 10 years, then it is good choice for your application. Next is we have to understand what is the color. Okay. So the color of LED must be like chosen properly, whether you need red color or green color or blue color, orange color, yellow color, white color, amber color, combinations of multiple color. Let's say only one LED package is there, but you need to have 3 colors in that. Okay, like red, green and blue, all these 3, or a combination of yellow and green, or a combination of red and green. So like that LEDs are coming these days, so that you don't have to like worry about. What happens is, how do they work is, basically this is my LED symbol, and this is my anode and this is my cathode. Okay. So let us say you have to have 2 color LEDs. So in that case what happens is, 2 color LED will be either like this, it will be, one will be this and another will be this. Another kind it can be like this. Okay. So common cathode it will be, one LED will be this, like this, or another combination can be like this. So it depends on like how the LED has been configured. So you have to choose like your required color based on the applications. Moving to the other parameters, we have to have configurations, whether it is like configured as I mentioned just now, that whether it is like a configured common cathode or common anode, or like anode cathode. So as you can see, this is cathode, this is anode, so anode cathode or common cathode or common anode, something like that. So this is how something like configuration. Some other configurations are also like bidirectional or unidirectional. Okay, so these are the combinations that you have to understand about the configuration. Coming back to see about the lens color, whether you want to have the lens color, you know, like some green color or blue color or white color or colorless. So generally people prefer colorless. Okay, colorless, so that lens will not get, you know, like visible, only the color of the LED will be visible. Lens transparency, sometimes you do not want to be very transparent, it may be diffused with some color. Okay, otherwise generally people do not want any transparency, so they need transparent lenses. Okay, if you see the millicandela ratings, okay, so ratings is basically, it is kind of, you know, like going to give you the brightness standard. So millicandela rating is in terms of like, you know, 40 MCD or, you know, 120 MCD or something like that. So it depends on the you know, like brightness of LED that you are going to choose. So higher the MCD rating, higher will be the brightness. Okay, lens style, so lens style, it will be, you know, like whether it is bonded round or it is, you know, like flat, round or flat or, you know, like curved, something like that. Okay, lens size is very important thing. It depends on the, you know, like a PCB size where you are going to use, or the places where you are going to put your LED. So whether it can be you know, like either on SMD or through hole, as I mentioned you. So let us talk about lens sizes. In that, what we can do is we can have a packaging. Okay, so if you see some of the packages, very standard packages are also coming these days. We have 0402, 0603, 0805, 1206, 1210, 1816. Various other parameters are also there in packages. Then some of the good packages are like 2 PLCC, 4 PLCC, 5 PLCC, 6 PLCC, all these are there. Then we have SMD packages, 2 SMD, 4 SMD, 6 SMD. We have Gulvik packages, we have XCL package or radial packages. Okay, so these are the different packages that is available with the LEDs. So we have to understand which kind of you know, like a package or how much space is available for us. If we have to have a very compact PCB, then you will go very small size LEDs. Okay, now coming back to other parameters, we saw the packages. Then let us talk about voltage forward. Okay, so voltage forward is basically, you know, like in any LEDs that you will see, it will be mentioned like whether it has a 1.8 volt voltage drop or 2 volt voltage drop or 2.2 volt voltage drop or 2.7 volt or 3 volt or 3.2 volt, something like that. Okay, so let us say you have to have a 5 volt indicator. Okay, then any of these you can choose, but if you have to have 1.8 volt indicator, then you cannot choose even this one. Okay, so the voltage drop must be lesser than the supply voltage. Okay, so this is how you have to understand. If you have to have a 3.3 volt power supply, then your aim should be to select an LED with voltage forward drop less than 3.3, which can be up to 3 volt or something like that. Okay, then there is a parameter which is called as current test. So up to, you know, like current test, generally they give 30 milliampere they would have tested, or 20 milliampere they would have tested, or 10 milliampere they would have tested. Okay, so what current capacity do you want? Based on that current test setup, you can take you can choose your LEDs. So generally 20 milliampere current test is more than enough for any of the general applications LEDs. Very important thing is viewing angle. Okay, so at what angle do you want to see? Whether you want to see up to around 30 degrees, 30 degree or 45 degree, or, you know, like a 90 degree or 120 degree or 145 degree or 160 degree. So it is like, you know, up, suppose it is 30 degrees, so this 30-degree angle only you will be able to see the LEDs. Okay, this is how it will be. If you want to have, you know, like 145 degree, then it will be more than one you know, like 90 degree, that is up to this much it will be visible properly. So like that it is the viewing angle. Okay, and grade and qualification, as you know, like a lot of grade these days are coming, whether it is automotive grade or it is general consumer grade, like industrial grade. So if it is qualified with AEC Q101 or AEC uh, Q102, so something like that you can always look into. Moving to the like mounting type, as I already mentioned you, whether you want it SMD, that is surface mountable, or through hole, that is like a through hole type, and already you understand, right? Then what is the dominant wavelength? Okay, so dominant wavelength is nothing but it depends on the color of the LED, whether it is green color, then there is a respective wavelength. Based on that only the color is decided. So what is the wavelength? Based on that the color will be decided. So I will be telling you like what wavelength will be there required for what color. So red LED it will be around 800 nanometer, or green LED it will be it depends, like I don't remember the exact the wavelengths of each colors, but it will be given in the data sheet. Similar to that, peak wavelength will be there, where the LED will be seem to be very bright. Okay, so as we have already talked about size, dimensions and packages, so you have to look into these parameters. You can have a choice of like whether you have already an LED that is there on your board and you want to have a replacement because that has gone obsolete. So these parameters like size and dimension matters a lot, okay, that you do not want to change the size because you may end up changing your PCB, right? Good. And some of the last like parameters that we have to understand is, as I very first I told you, product status that you have to understand, like whether it is active or not. Otherwise choosing an LED which is going to like go obsolete or may end of life after some years, then it is not good. And you must have RoHS compliant LEDs, then only it is good. Otherwise it will be a problem in your C certification, or like some certification for your products. So if you see some of the LEDs pictures that I have taken from website, these are generally taken from Worth Electronics website. So this is the color LEDs, as you can directly see. This is dark green, and this is like bright green. This is yellow, this is red, this is dark red. So, and this is like colorless LEDs, like watercolor LEDs, but they have the colors, like once you switch it on, then it will be like green, blue or whatever color that is there, okay, but you will not be able to understand just by seeing them whether it is green LED or whether it is red LED. Similar to that, we have surface mountable LEDs like chip LEDs. So it is full color LEDs, or like this is bicolor LEDs, like two will be there. So bicolor LEDs, you can see there are four buttons, I mean four pitch is there. And this is monocolor LEDs, only two pins are there. Here it is four pins are there, right? Now let me tell you some of the parameters that we have to see in the data sheet, okay. So any LEDs you will open, you will see the data sheet something like this, like relative intensity versus your wavelength. So this is the part number that I have taken, which is actually 151031VS04000, okay. So this is a green color LED, and you can see relative intensity is actually increasing, like up to 100% it will go at this particular wavelength, which is going to be around 570 nanometer, okay. So this is how you will be seeing at 570 nanometer. This is having the highest wavelength or highest intensity. If you like seeing a little bit lower intensity, then it will be giving you a wavelength of lower than 570 or more than 570, okay. Coming back to voltage forward, like forward drop. So what is the forward current required and what is the forward voltage drop? So as you can see, close to like 1.8 volt or something, 1.8 volt or something, it has not even switched on, okay. So you have to apply a voltage more than 1.8 volt to switch it on. Now as you start increasing the voltage more than 1.8 volt, as you can see the forward current has started increasing, okay. So you can see up to around 2.3 volt it has reached to infinite current, okay. So this is kind of a diode, as you know already diode characteristic. What is the diode characteristics? In the beginning it will be like this, and then slowly it will increase, right. So this is how your knee voltage or V like F something like that is there, okay. So basically you have to make sure that after putting a resistor and then you put your LED, and you have to make sure that this particular voltage V in, and this is your resistor, and this is the current that is going in the LED. Okay, so you have to make sure the resistor is chosen in such a manner that the current is going up to around 20 milliamperes or something like that, so that it have a proper voltage drop across this particular LED. Okay, let me give you a proper detailed a description of data sheet that it provides you. So this is the part number that I have taken. Okay, as you can see, it gives you a power dissipation rating which is going to be 72 milliwatts. Okay, so 72 milliwatts means, let's say 20 milliampere current is there and 2.2 volt drop is there. Then what will be the total drop that will be there, total power dissipation that will be there across this? 4.4 milliwatt, right? It is 44 milliwatt. Okay, so it is less than 72, so this is good to go ahead. So like that you have to understand. Similar to that, peak forward current is going up to 100 milliampere, so you can supply 100 milliampere current across this particular LED. Continuous forward current that you will be you are supposed to give across this LED is 30 milliampere. You do not suppress this LED with more than 30 milliamperes. So you have to design your resistor, or you have to decide your resistor in such a manner that, let's say 3V3 you are giving, this is your R, and this is your, let's say R1, and this is your LED D. Okay, so you have to make sure the value of R1 must be in such a manner that after this voltage drop, the current through this, let's say I1, must be less than or equal to 30 milliampere. So how do you decide that one? 3.3 minus Vf, which is voltage drop across the diode or across the LED, divided by R1, must be less than 30 milliampere. Okay, so this is how you decide your R1 value. Got it? It is also giving you ESD threshold or human body model, so that is going to be 2 kV, that is 2000 volt, and the junction temperature it can go up to 95 degrees centigrade. Okay, this is actually a aluminum indium gallium phosphide based, and it is emitting color is red color. So this is a red color LED, and this is chip LED. Okay, various other parameters that you can see in the data sheet is what is the package size. So this you can see it is like a 1 millimeter, and here I have made it like this. So here it is 1.2 mm, and this is like a round shape which is 0.2 mm pitch, right? And this is the total length which is going to be 2 millimeter. So all lengths are in 2 millimeters, and as you can see this is a polarity marking. So if you see the part physically, if it is dark black, then it is a cathode and it is anode, the other one is anode. Okay. Next is some of the other electrical parameters in the same data sheet will be given like this. Let me just increase it a little. Okay, so the peak wavelength, as I told you, 20 milliampere current, the peak wavelength will be 630 nanometers. So for red color, 630 nanometer is the peak wavelength that will be there. Dominant wavelength will be 625 nanometers. Coming back to luminous intensity, which will be 150 millicandela. Okay, and then we have voltage drop, which is going to be 2 volt nominal voltage or typical voltage drop, and 2.4 volt will be maximum voltage drop. It cannot drop more than 2.4 volt. The spectrum bandwidth will be 15 nanometers. So as I told you just now, that this is the wavelength that was there, right? So this spectral wavelength will be width will be 15 nanometer only. Okay, coming back to reverse current. So reverse current will be just 10 microampere, and we have viewing angle. So viewing angle you will be seeing 140 degree. We have ROHS approval, reach approval, halogen free and halogen free. All these things are always there. So this particular LED is a good part for your selection. You can see wavelength and all these intensity. So let's say relative intensity versus wavelength spectral. So how it is going to be? 630 nanometer. Okay. So in the data sheet you will see the color itself is made in that one, so that you don't have to struggle whether it is red LED or green LED. It is definitely red LED that we have seen. Okay, so this is the relative intensity. So if your wavelength is emitting up to let's say 10 nanometer, then it will be giving you 40% intensity only. If it is emitting at 100 like 630 nanometers, then it will be giving you 100% intensity. Okay, similar to that, we had voltage forward drop that I told you. So if you are going to give a 2-volt drop across the LED, then it will be properly illuminated. So you have to make sure the resistor design and the LED across the LED must be in such a manner that your V input minus this VD VF, that is divided by R1, must be meeting this spec. Okay, other is we have luminous intensity versus forward current. So as you can see, the forward current starts increasing, the intensity also starts increasing. Okay, so if your current across the LED is more, like I is increasing, the intensity will also start increasing, that it will be seen little bit bright. Okay, now coming back to the power dissipation part, or derating curve. So as you can see, the forward current is going up to 30 milliamperes and we have ambient temperatures. Okay, so if you are continuously working at 30 milliampere current across the LED, then up to 50 degrees centigrade only you can work, otherwise it will get failed. Okay, so if you are increasing up to 80 degrees centigrade temperature of your PCB, then you cannot work more than 15 milliamperes. Okay, so this is the I in milliamperes and this is the temperature in degree centigrade. Okay, so you have to make sure in this derating curve, your understanding must be the current across the diode must not increase beyond this particular region, otherwise your LED will fail. Okay, so this was all about the LED parameters in the given diode, and I'll suggest you can always see a part in DG key or Mauser. These are very good online distributors. So if you see quickly let me give you a part number which is chosen like this. So you will see very easily they are giving you various parameters and various values. Okay, so as you can see, the part status is active, this is red LED, the standard configuration is there, the lens color is colorless. Then we have lens transparency, so transparency, it is clear, and then we have millicandela rating, that is 250 millicandela. It has flat top. Okay, then lens size is just a 1.1 millimeter cross 0.7 millimeter, that is length cross width. Okay, and then we have voltage drop which is 2 volt, and then we have current tested at 220 milliampere. So you have to make sure the current that is going through the LED must be less than 20 milliamperes. Okay, the viewing angle is 140 degree. We have surface mount, we have peak wavelength and dominant wavelengths are 630 nanometer and 625 nanometers. We have package size is a standard package which is 0603, and the size of this particular LED is 1.6 cross 0.8 mm, and we have height at 0.8 mm maximum. So this is the very good parameters that is put together in DG key. Okay, the DG key I have written already. There are other online distributors like Arrow, then we have Mauser, and various other online distributors are also there. So you can see all these parameters listed out very properly. So hope you have a good understanding about how you can select a particular LED for your application from various manufacturers, whether it is through hole LEDs or cheap LEDs, or whether it is single color LED, that is monocolor, or bicolor LED or tricolor LED. Okay, so any LEDs for your particular applications. As I told you, various applications are also there. Other than that, we have like floodlight LEDs or automotive LEDs and all. That I am not discussing. I am discussing only for the applications of PCB indicators or voltage rail indicators and all. Okay, so if you do have any requirement of how to select an LED, or if you are struggling with finding a perfect LED for your design or for your application, please put down your queries in the comment box and we shall be able to answer you out. Thank you so much.